Hello, my name is Jacob Creech. I work on the developer relations team here at Solana Foundation. I'm joined today by Ashwin, who is a consensus engineer at Anza, and today we're going to talk about how consensus works on Solana. All right, so can you give a quick overview of how consensus works on Solana, and then we can deep dive into different parts?
Yeah, sounds good. So consensus is basically the part of Solana that deals with how blocks are added to the chain, and specifically how nodes vote on these blocks, and then eventually these blocks get finalized and are part of the canonical chain.
Okay.
So I guess we can start a little bit with how blocks are produced,
Sure.
and then we can get into the voting.
Let's do it.
So originally, there was this Genesis block, which is block 0. And then we have this schedule, which is basically who's going to produce the next block. And if you produce the next block, you're called the leader. So you have this leader.
This is the leader schedule, right?
Yeah, the leader schedule. And each leader gets 4 blocks.
Okay.
And the leader schedule is determined by stake. So the amount of stake that's delegated to you determines how many blocks you eventually get per epoch. So
Okay.
if you have a lot of stake, you're going to get a lot of spots in the leader schedule, and you're going to get to produce a lot of blocks. If you have a small amount of stake, you might not even be chosen for that epoch. And so, yeah. So
Okay. So you said 4 blocks. These are like guaranteed consecutive blocks,
Yeah.
but you could potentially, based off a stake, have more than 4 blocks inside.
yeah,
But you could divide by 4 to get your different sections that you get to vote.
exactly.
to
You might
produce
make blocks like 1 through 4, and then later make blocks like 101 to 104.
Got it.
You could have multiple iterations, right?
Got it. Okay.
So, we had the Genesis block, and then the first leader, made blocks 1 through 4. And so they make these blocks, and then they broadcast them out to the network. And then the duty of the rest of the validators is to execute the transactions in these blocks, verify that everything is valid, everything checks out. And if it does, then they vote on the block.
Okay.
And their vote basically symbolizes that, okay, this block is good. I vote to add it to the chain so that when it becomes finalized, it's, part of Solana forever. These transactions are final.
Okay.
So
So I think you went through bunch of different concepts there. I want to back up.
Yeah.
So first, you said that hey, these are broadcasted.
yeah,
I think, and you correct me if I'm wrong, is it on Gossip and on Turbine?
so it's only through Turbine.
Okay.
So each block is split up into multiple shreds, and then you send a shred through the Turbine tree.
Okay.
And so it's a whole thing of how it's done. But essentially, you don't have to worry about the super nitty gritty of how it's broadcasted. It's just everyone sees these blocks, and they're able to reconstruct and replay all of the transactions in the blocks.
Okay. And then another one you said is when the blocks are finalized. What does finalized mean in this context?
Okay, yeah. So finalized basically means the block can never be rolled back. So no matter what happens further down in the consensus algorithm or people change their minds, this block will live forever as part of the Solana blockchain. The only way you could get rid of it is if, you did a hard fork and started a new chain off of some parent block, which is,
This would be some large block reorg based on the hard fork.
yeah, exactly.
Okay.
Which is unlikely to happen.
You basically have to do a restart or something.
Yeah, you have to do a restart. You have to get all of the validators on board and have them all erase the block from the history. So once it reaches finalized for all intents and purposes, without forking the entire chain, doing a Ethereum classic,
Okay.
the block, you won't be able to roll back the transactions of the block.
Okay, so that's the finalized state.
Yeah.
I know that there's also different commitment states of
Yeah.
confirmed and processed. What is confirmed in this context?
Yeah. So, we can go. I guess we can go through it. So, confirmed just means that 66%, greater than 66%, have voted on it.
Okay.
So, for example, block 2, right? If 66% of people vote on block 2, then block 2 is confirmed as well as block 1, even if people didn't vote on block 1, just because block 1 is the parent. So the confirmed status kind of passes to your parents as well.
Okay.
Um,
All right. So then going back, like, how are these voted on?
right. So each validator has this structure called a tower, and a tower is basically how the structure that organizes their votes and keeps track of various consensus things. And then at intervals, they will send their tower on chain. So each validator has a vote account, which is basically an account that belongs to them on chain. They will sync their tower that they have locally to the on-chain tower. And once it's synced, anyone can view their vote history by looking at their vote account on chain. So their votes become accessible to all the other validators and any other participants.
Okay. So just make sure I understand.
Yeah.
So say we have this account here, right?
Mhm.
You said it was the vote account, right?
Yeah.
So we'll just put VA there. This would have the tower data? Is
Yeah.
that right?
Yep.
So tower data. And whenever the validator was called this a validator, they're sending transactions basically to update this whenever they're say whatever the validator and leader schedule is doing this, they say, hey, this is one. They'd send a transaction out to update the tower to include one, saying this is what I believe is the next block in the slot. And then all the other validators, so we'll just have like a cluster of validators. They're watching this, and then they're vote. How did the votes actually get stored and updated?
Yeah. So we can go through that. So we can kind of go through the structure of the tower a little bit. So the tower, as the name implies, it's kind of a stack.
Okay.
So the idea is that as you vote, you keep adding things to the top, and then potentially popping things off of the top as well. So here, for example, everyone votes on block 0, suppose. So that'll be the bottom of your tower. And then let's say our validator voted on block 1 and then block 2, right?
Okay.
So this would be their tower at, after they finish replaying block 2, this is their tower. And then they would send this in a transaction. And hopefully that transaction would then make it in block 3.
Okay.
And then so if you looked at their vote account in block 3, you would see their tower, and their tower would have, 0, 1, 2.
Okay. So they're saying like, hey, I believe or I agree with 0, 1, 2 as the next blocks to be finalized. And then if you see them in block 3, that means like, hey, they made it into block, and that was voted on by whatever validators were voting on that.
Exactly. So if you have, a different validator, let's say this is validator 2, and they're a little bit behind. So they've only voted on their tower, they've only voted on 1 and 0 at this moment. They would also send their transaction, and this transaction might land in block 3. So their tower, if you looked at their vote account, it would only have 0 and 1 in it.
Okay.
So then if you are a validator and you've been following along and replaying the blocks as they come, once you replay block 3, you'll see, let's say this is validator 1. You'll see, okay, validator 1's latest vote is here, and then validator 2's latest vote is here. And you do this for all of the validators.
And this is to find like the confirmed state and the finalized state.
Yeah, so this just gives you like an overall picture of how, where the network's at,
Okay.
who's voted on what. And then the important thing about votes is they're also determined by stake.
Okay.
So the amount of stake delegated to you impacts the weight of your vote. So when I say, 66%, that means 66% of total stake.
Got it. That's the super majority rate?
Yeah, super majority. So it's like greater than 66 is technically like 67.
Okay.
But yeah, for the super majority. So, maybe validator 1 is a highly staked node and has, 10% of a
Right.
stake. which doesn't happen on mainnet, but for this example. And then validator 2 is, a smaller node only has 1% of the stake.
Okay.
And then in our local view, we could sum this and say, this block has 11% of the stake because validators one's vote for 2 also counts for 1. And then this one only has 10% of the stake at the moment.
So you're keeping track, all the validators are keeping track of the total percent voted on stake. And as soon as it reaches 66 or greater than 66%, and that is a confirmed block. And then the additional rules for finalized. What are the specific additional rules for finalized?
Yeah, so I can go into that. It basically involves lockout, so we could probably talk about that now.
Let's do it.
Yeah, so lockout is basically your commitment level on a fork. So the idea here is that if you're voting consecutively or very close to consecutively, that's a good thing. Like if you vote on 1, 2, 3, 4, that should be treated. That should be weighted more heavily than if you only voted on 1 and then voted on 4.
Okay.
Like maybe 2 and 3 were missing. Like the leader never sent out 2 and 3, so you were only able to vote on 1 and then vote on 4.
Okay, so you said fork. Is that what a fork is, or what is a fork?
Yeah, so fork is any time there are multiple children coming from the same block.
Okay.
So yeah, I guess we should talk about forks
Let's get
first. So the most common thing that can happen to create a fork is a leader can't build a block until it's finished replaying the parent. So for example, if I want to build block 4, then I need to have the end state after I process all the transactions in block 3 in order to start building block 4.
Okay.
Because I can't tell, like if you're doing a transfer, I don't know if the transfer is going to succeed or fail until I know your wallet balance, which I'm not going to know if there are transactions in 3 that touch your account.
Right.
So what could, like, one of the most common cases that happens, so this is all, leader 1 made these 4 blocks.
Okay.
And then leader 2 comes in and wants to build block 5. But maybe block 4 was a little slow to broadcast.
Right. Say they only have 2 or something, or
Yeah.
like 3. Let's say
They
have 1, 2,
only
and 3.
only have 3. Leader 4 or block 4 was too slow to broadcast. It took too long to replay the transactions. Leader 2 is going to build, block 5 off of 3 because that's the latest block that it has. It doesn't want to miss its leader window, so it's just going to build a block.
Okay. What is the leader window?
So you have 400 milliseconds plus a little bit of grace time to pack your block and submit it.
Okay.
If you don't submit it within that window, then the next block is ready to be submitted. So they can.
It's just a skip slot.
Yeah, it's just a skip slot.
So slots are basically opportunity to produce blocks, but
Right.
not necessarily having blocks.
Exactly.
Skipped.
Yeah.
Okay.
And if you take too long to produce your block and the next guy produces his block and people replay his block first, they're going to vote on his block.
Right.
And then your block is definitely going to be skipped.
So yeah, so if this reaches, I know we're probably jumping a little bit ahead, but if this reaches 66%, gets confirmed, this will be a skip slot.
Exactly. Yeah.
Okay.
So this is the basic idea of how forks can happen. And then, this problem could continue as in, this guy builds 5 through 8, but then the next leader, leader 3, so this is all leader 2. Leader 3 actually did receive 4 on time, and he actually did vote on 4.
Okay.
So he wants 4 to be as part of the canonical chain. So he's going to build his 9 off of 4.
Oh boy.
Right. So this is leader 3.
So how do you choose which fork is correct?
Yeah. So that's what this weighting does. So right now our fork choice algorithm, it basically keeps track of the vote counts for each block and updates just this structure, which keeps track of total stake. Right. So if leader 3 had seen that, block 4 has 51% of the stake,
Right.
and then this block 8 only had 49% of the stake, he will choose to build off of block 4.
Why?
Because block 4 is slightly heavier than block 8. His choices are to either to build off of some leaf, so like either 4 or 8, because those are like the deepest blocks that he's replayed. And then to determine which one to build off of, he looks at this weighting on their forks, and this fork at this point has 51%. This one has 49. Then he might.
That's like the happy path.
Yeah.
What's to keep him from just saying, nah, I like this set of blocks better because maybe I made a lot of money in that.
Exactly.
Start voting on put 9 on top of 8.
Yeah. So there's nothing stopping him. Block production is not part of consensus in terms of like, if he wants to, he could build off of 1. Like there's nothing stopping him except the fact that when people vote, they also use the same metric. So if I'm a validator and this is my current view of the world, I'm always going to vote for 9 as opposed to.
Is this assuming like an honest majority though?
Yeah, this is assuming you have a modifying validator, you're running the stock code. It's always going to pick whichever the heavier fork is based on the towers that you observe.
And when you say heavier, it's just the percentage voted on.
Yeah, just the percentage voted on.
Okay, so how big can these forks get before we run into issues then?
So the idea with Solana consensus is we want to make it as asynchronous as possible in terms of ideally consensus should be able to run behind block production at any interval.
Right.
So in theory, the fork could be as large as possible until you reach a point where validator is out of memory.
Okay.
So the idea with that is if a block is finalized, then as we said before, there's no way it can be rolled back. So you can kind of prune all of those related information and lower your memory footprint. But if you haven't finalized a block in a long time and these forks get really big, you have to store all of the accounts details, all the metadata, various things, and that will eventually blow up your memory.
Okay. Yeah. So question, I've seen this happen where it's like, let's say this one is the 67. So we know this is good.
Yeah.
Is that like considered root, or how do roots work?
Yeah. So the way roots work is we can get into the lockout stuff now. So there's.
What is a lockout?
Yeah. So lockout is kind of like when you vote on something, you want to say how confident you are in your vote. And the lockout is kind of a measurement of your confidence.
Okay.
So for example, when you just start voting and you vote on 0, your lockout starts out very small. And the first number that it starts out as is 2. Okay.
And why 2?
They just go in powers of 2.
Okay.
Yeah. And then you vote on 1, right? And then now when you vote on 1, every vote for 1 is also implicitly a vote for 0, right? Because 0 is 1's parent.
Right.
So now you've kind of voted twice in favor of 0.
Okay.
Because you voted on 0 and you voted on 1. So in this case, we will double the lockout of 0, make it 4, and then 1 is 2.
Okay.
And then let's say you also vote on 2, right? Now a vote for 2 is also a vote for 1, also a vote for 0. You double the lockouts again, and then you get this.
Okay.
So now, because you've voted on the fork descending from 0 multiple times, the lockout for 0 has increased exponentially.
So this lockout number is the confidence that you have for it?
Yeah, kind of like the confidence. It's a measurement of the confidence you have.
Okay.
Right. And the idea behind this lockout number is if you vote sporadically or maybe there are skip slots, then slots on the tower could expire. Right. So in this example, you have your lockout, and then you have this thing called your last locked out slot, or basically like expiration. And what this means, this is the sum of the slot that you voted for plus the lockout. Right.
Okay.
So it's just a sum of these two. And the idea behind this is if you take a while to vote, then your vote on the tower could expire. So in this example, let's say, you didn't vote for 3, and then you didn't vote for 4 either. You ended up voting for 5.
Okay.
Yeah. So here you vote for 5. And then if you notice here, this vote for 2 actually expires at slot 4.
Oh, okay.
So when you vote for 5, you expire and pop off this vote for 2.
But the 5 is still implicitly voting for 2, right?
Yeah, the 5 is voting for 2, but the
It
idea
doesn't matter as much.
it don't. Yeah, the idea behind this is because maybe 3 and 4 were skipped, or for a moment you were unsure, you thought some other fork could be higher, and so you didn't vote on 3 and 4. All of these things are bad for confidence.
Okay.
So we expire the vote for 2, and we don't increase our confidence on 1 or 0. The lockouts still stay the same.
Okay.
But then, if we were to vote for 6, then we would
Get everything down.
update everything down. Okay. And then the only other thing is, I'm going to go back to,
So what happens if someone doesn't vote for a very long time and all of their votes expire?
yeah, so that can happen. If you don't vote for a very long time, then you didn't have confidence in the network for a very long time. So your tower should be reset
Right.
to, only having a lockout of 2.
Would that then make these numbers go down, basically? So if you're at 67% and then you don't vote for a very long time,
Yeah.
could that potentially go below 66?
So this specific slot would never go below 66.
It's set.
Yeah.
But if you could you go from 50 to 49 because of lockout or expirations?
Yeah, so you could, if you switch, so a vote doesn't expire on chain in terms of if I voted for 3, and then I never voted again, my vote for 3 is always going to be there.
Okay.
It's part of the record that I voted for 3.
Right. Because it hit 67%, you're good to go. It's set.
Right. It doesn't even matter that I hit 67%. It's just my last vote. And it's been broadcasted to everyone. So everyone knows my last vote was for 3.
Okay. So
So forever, until I vote again, they will always count my stake as part of 3.
okay. So in that expiration does not matter for last voted on slot.
Yeah.
Okay.
Yeah. Expiration is only for, your local bookkeeping in the tower
Got it.
to determine what I'm going to talk about next, which is actually switching forks.
Okay.
So let's say in this example, you voted on 2, you voted on 4, and then you voted on 9. Okay. Actually, it's this. Let's do it the other way. So you voted on 5 and 6.
Okay.
Okay. So in this example, you voted for this bottom fork, right? And then, so you voted for 6, and then eventually, leader 3 decides to build block 9, and block 9 contains a bunch of these tower sync transactions that we were talking about that updated the vote accounts, and this is what clued you in that actually 51% of people voted on 4. So now in your bookkeeping, you realize, I made a mistake. I'm actually, I've been voting for this bottom fork when this fork is heavier.
Correct.
So now I want to stop voting here, and I want to switch back to what is the correct fork, right?
Okay.
So maybe I want to vote on,
This is changing a vote then.
it's basically changing what your latest vote, what fork you're showing support for.
Okay.
But the fact that you voted on 6 will always remain.
Right.
And then,
Well, how would it be? Would that vote for 6 then be in the block of 9?
no, so the,
Where is that stored?
so the vote for 6 will either be in block 7 or block 8.
Okay.
Yeah.
But those are not chosen. That's what I'm trying to get is hey, if let's say the canonical fork ends up being this,
Sure.
and say you voted on 6.
Yeah.
Where does that stored then? Because these are not on the chain.
Yeah. So once it becomes the canonical chain, it doesn't matter.
Of course.
Yeah. So this is only for like when we're still trying to figure out what's going to be finalized.
Okay.
Validators will replay both block 8 and block 9, and they'll see that, in your vote account for block 8, it showed that you voted for 6. And then in your vote account for block 9, it shows your last vote was 2.
Got it.
Because a vote for a specific slot can only land in the vote account for that fork. So if I vote for 5, it can't land in 9.
Got it.
It's only going to show up in the blocks descended for 5.
Okay. How big can these towers get?
Yeah, so the tower reaches a maximum depth of 31.
Okay.
So the idea behind that is, let me first go over how the switching actually happens. Let's make this 7. Yeah. Okay, so the last locked out slot here is 9, right?
Got it.
And then this one's also 9. This one's 10,
1732.
32. Yeah. Okay. So every time you want to switch, so here my last vote was for 7, and then I'm looking to switch to 9, right? I got to walk the tower back and get rid of any slot that doesn't belong to this fork, right? So if I want to vote on 9, then I can't have these 2 guys in my tower.
Okay.
Because they're not part of the fork that 9's on.
So whenever you do if say you're changing your vote, then whatever transaction you're sending would be adding 9 to 2, your tower of 2, I guess?
Yeah. So ideally, but the problem here is that I can't pop these guys off yet because their last locked out slot is 9.
So you have to wait till afterwards?
So I have to wait till 10.
Oh, okay.
Yeah. So instead, what would happen is, I'd wait till 10, and then, so I can't vote on 9 because I'm still locked out on 9. And then when I vote for 10, it'll look something like this.
Okay. So then your tower ends up looking like from 10 to 1, and then you're good to go.
Yeah. And then notice I didn't update any of these because since I popped off a bunch of votes, I haven't increased my confidence here. And this won't increase until I'm back to a 2, 4, 8, 16. Once I reach the same depth, then I'll start doubling the lockouts again.
So does this tower get pruned based off of what was voted more than 66%?
No. So the way that this tower gets pruned is, first, I guess, does the switching logic make sense?
It makes sense to me right now.
Okay. And then the only other thing is, the amount of time that you have to wait to switch is based on the lockout. In that example, we only had to wait 1 slot.
Right. It could be a huge amount.
Yeah. So say, for example, you voted on 5, 6, 7, and 8. So you showed a lot of confidence in this fork, right? So now for 16, these ones don't matter right now. And then now you want to switch to 9, right?
Right.
If you look at your last locked out slot, we're talking big numbers. We got 21, 14, 10, right? I have to
13 and 18.
5 plus 6. So 5 plus.
Sorry.
Yeah.
It's not lining up.
Yeah.
Okay,
my
got
bad. So I voted, all the way to 8. Realized that 9 is actually the fork that I want to be on. In order to switch, I have to pop off 8, 7, 6, and 5.
Okay. So you have to wait until slot 21.
I have to wait until slot 22. Yeah.
22, okay.
Yeah, I can't vote until slot 22.
Oh, and that could really hurt, causing or doing this could really hurt you because then you don't get rewards.
Yeah, you don't get rewards. I guess one thing I should mention is, every time you vote on a slot and that slot ends up getting finalized, you get credits for participating.
What are these credit? When you say credit, is that the staking reward? Or
Yeah. So the way it works is there's this credit system that keeps score, and then at the end of the epoch, depending on how many credits you have relative to the total amount of credits earned by everyone, you get a portion of the inflationary awards.
Okay.
I believe.
Got it.
So yeah. So if you continue to vote, you'll be locked out for longer, and it's exponential because the lockouts are exponential.
Okay. So
Yeah.
this is like, hey, if you keep voting on the wrong fork, it hurts you in
Yeah.
the long run. What is keeping you from waiting to vote?
So yeah, if you could do one thing, which is just never vote until you're absolutely certain
Right.
that something is going to be finalized for sure. So the new credits mechanism that's coming out, the way that you're awarded credits is based on how quickly you vote.
Okay.
So if you voted on 3 and then you synced your tower and the tower showing that you voted on 3 was present in your vote account on 4, that's a 1 slot difference. You're gonna get the maximum amount of credits.
Okay.
Instead, if you waited until 12 and then at that point you were sure 3 is gonna be finalized,
Oh, you could get a lot less credits that way.
you get a lot less credits because your vote account will be updated in 12 or 13 or whatever.
Okay, so the distance of your vote also. I got it. Okay,
Yeah.
that makes sense.
Yeah, so that way you incentivize people to vote as quickly as possible.
Got it.
Which helps us reach confirmation as quickly as possible.
Got it. That's cool.
Okay.
I didn't know about that.
Yeah.
So I think I asked her, like, how big can these towers
Yeah.
get? You
Okay.
said 32 or?
Yeah. So now that we have, I think, lockouts more or less explained, what happens is, once you get to, I'll just do it from 1 to make it a little easier. 1, right. So, this is 2, 4, and then this one is 2 to the 31 in terms of lockout, right? And then now let's say you vote on 32. We just picked an arbitrary number, obviously. What would happen is you would vote on 32, and then the lockout of this guy is 2 to 32. This is a number that's so big
Right.
that for all intents and purposes, you're never going to be able to switch off of 1.
Right, you're probably using some number that might even be too high or something.
Yeah, it's just going to be too high.
Some type.
And if you wanted to switch off of 1, so say there was some other fork here being built, and if you want to vote on this block, then you have to wait till 1 has left your tower, which means waiting this number of slots, which is
Never
way too big. So what we do is at this point, we remove this from the tower.
Okay.
So now our tower starts at 2, and then we say that this is our root.
Okay.
So all it means for something to be a root is it has reached a tower depth of 32 or more.
Got it. So whenever we're voting on a bunch of forks, right? If I don't want to draw 32 two notes here.
Yeah.
But basically, for finalization, we're waiting for that root to move across the block, so the tower gets pruned on the various, I guess, validators.
Exactly. So yeah, we can talk about finalize means rooted by.
Got it.
So as part of your vote account, you have the tower, but then you also have your root. That's also part of the vote account. So
You're keeping track of the root based on the vote accounts as well.
yeah,
So you're both keeping track of the vote, just the straight up vote.
Yeah, the
as
tower.
well, the tower.
and also there's a field for the root.
Okay.
And so, if I look at, well, I guess these numbers are too small, but if I looked at, some block, I can see what everyone's root is. And then if at least 66% of the cluster has rooted either this slot or some child of this slot, then it's considered finalized.
Got it.
Yeah.
So what happens if cluster has trouble voting on a fork for 31 slots?
So there's just no vote on that fork for 31 slots.
But I mean, like, there's so
Maybe if you draw an example.
yeah. So say we have 3, we have a bunch of other ones.
Yeah, you can. I think we've covered this.
We should be surprised.
Yeah.
So say we have a bunch of other ones. So we have a bunch of other ones of just. So a bunch of other ones, and then this will be, let's see, 3 plus 30. We'll just call it 35 or something.
Okay.
I guess it won't work. 36. 36.
Sure.
36.
Mhm.
And there's a bunch of other forks in between. So when we get to 36, we still haven't reached 66% on any of them. Is there any issue with like that as the tower depth? Because there's a bunch. I guess that you don't have to vote. Okay, so you don't have to vote on your 36 implicitly voting for that, and then okay. So I guess there isn't a problem. I guess where I'm trying to get is that if we have 36, which is higher than the tower depth, do we have a problem because suddenly it's like too large of a number? But I think the answer, and you can correct me if I'm wrong, because we got to 30, or because we're voting on 36, we're voting on everything before, and all the rest just don't matter. And so like the tower will, you'll just not have the tower updated with the rest once you get to 36.
Yeah. So the actual number doesn't matter. It's only the lockout
It doesn't matter
that
at all.
matters. Yeah. Like these numbers are in the millions, right? Because they're slots.
Right.
And the gaps between them only matter for the lockout. So in this example, like you voted on 3.
You'd have to have a very like, you'd have to not decide on a fork from a ton of slots, like millions of slots.
But even if you didn't, the worst thing that could happen, like in this example, you voted on 3 and then you voted on 36. 3 expires, 2 expires,
Right.
2, 4, 8, 1 expires, and even 0 expires as well, right? Because all of those have lockouts that are, their lockouts expire before 36.
Right.
So in the end, your tower would
Just be 36.
just be 36 with a lockout of 2. Yeah.
Just immediately expire, right?
Yeah, because I mean, the question is, why didn't you vote for 33 blocks?
Right.
You know, there's something going on. We have low confidence, so we shouldn't be, doubling down.
Right.
Yeah.
So this would likely not be a problem now, but it might have been a problem when creating the Genesis and container.
Yeah, yeah. Well,
We're
I
just
mean,
hoping that everybody continues.
yeah, I mean, even if this happens, what the network still recovers once people start voting.
Right.
Because eventually what would happen is you would build up enough lockout on 36 by voting on its
And
descendants.
maybe 5.
And 36 will get rooted. And once 36 gets rooted, all of these are also rooted.
Got it.
So you don't need to root like 0, 1, 2, all of those
It
specifically.
would have been really fun to watch everything happening.
Yeah.
Were you around when the Genesis?
I was not.
Okay. It would have been fun to watch that because that's like, I guess for Solana, it's like the Big Bang. So
Right.
It's like we're hoping that it continues.
Yeah, that it continues. I'm sure there were many roadblocks,
Yeah.
probably restarts, but yeah, I mean, so those are the basics of
So-
Tower BFT.
So I've heard of lockout violations. How does that work? And
Yeah.
what are those?
So there's a couple more things. The first thing is right now, the verification that we can do on these tower syncing transactions is super limited, because right now what happens is you have some vote program, right? The vote program for in block 9 takes in the vote, and all it can really check is, is the tower well formed? Like, is everything in ascending order? Are lockouts also in ascending order?
Right.
Descending order? And then are all of the slots in the tower part of my fork? And that's all I can check. But since the vote program is contained to one fork, it can't check, did he violate lockouts or any of the switching rules? So for example, the example that we had before where you voted on 5, 6, 7, 8, and then you're not allowed to vote on 9. You have to wait until 22, right? Because of the lockout. If I voted on 9 anyway, the vote program would take that vote and still count it, because it doesn't know that you voted on 5, 6, 7, and 8. All it sees is, here's my new tower with 9 on it. Everything looks good. Let's put it on chain.
Right. Okay. But what are the consequences of that?
Right. So the consequences of that are the validator is eligible to be slashed. So anytime you violate your lockout restriction, it's not currently implemented, but anyone can submit a proof that here are 2 votes. This validator clearly violated their lockout. And so we should slash their stake.
Isn't it just like social slashing today?
Yeah, so right now we don't have any mechanism to slash.
It's not programmatic. It's just social. Like
social.
You need a restart. You need some updates.
Yeah, you need to restart and manually edit their account.
Okay.
And remove stake. We haven't had to do that. We have monitoring tools running to see if anyone's violating lockouts. And so far, apart from like one-off errors, there haven't been any.
What does that keep someone from to cause a ton of lockout violation? Let's just say some validator is just like, I'm gonna just vote on all blocks.
Yeah, so you could vote on all blocks, right? And then once slashing, either social slashing or automated slashing happens, you lose your stake.
Okay.
And then once you lose your stake, then your votes don't matter as much. And eventually it'll get to the point where you're just not participating and you're just bleeding.
No one cares.
Right.
Okay.
And the whole point of consensus is to design it in an adversarial method in terms of we always assume that 33% of the stake is malicious when designing these protocols. So we want to assume that 33% is going to double vote, vote on every single block, switch around, do whatever, but we still need everything to converge. We still need roots being made.
Okay.
So that's the assumption that we're working with.
Got it. What does it keep someone from I know that there's been duplicate blocks. How does that get prevented?
Yeah, that's a really big topic.
Okay.
Maybe I think we can finish up on this stuff.
And maybe we don't have time for that.
Yeah, if there's time, we can do. Yeah, that's a whole separate thing. So I think most of this is understood. The only other thing is, which I think you touched on earlier, is how in this example, if you vote on 5, 6, 7, 8, you have to wait for a long time.
Mm-hmm.
But you could assume that this could extend, and I don't know, you voted all the way to 20, right? And then you'd have to wait a crazy amount of time, right?
It's to keep you from basically, if you don't want to lose out on your rewards.
Right.
That's what it is.
Right. So we have this safety mechanism, which everything I've described so far is asynchronous, where the validator can vote without having to really wait for the rest of the cluster. But we have this safety mechanism that validators choose to use called the threshold check. And it's basically, there's two ones, 38% and then 66%. And this is 4 deep, 8 deep. And the basic idea is when you double lockouts, so let's say my tower vote lockout, my tower here has 8.
Can't order it.
Yeah. This is 1. Then this is 2 to the 8. 2. Right. I think I did that right. So this is my current,
Your
lockout.
tower and your lockout.
My current tower, and then I'm going to go ahead and vote for 9, right? And I double my lockout. So every time you double your lockouts, you perform this check. So you check out what is the eighth deepest slot in my tower. So in this case,
1.
that's 1. Make sure that 66% of people have voted for 1.
Okay.
So that's votes for 1 or votes for a descendant of 1. And then do the same thing with the 4 deep. So this is 8, 7, 6, 5. So for 5, make sure that 38% have voted for 4.
Why is it 38%?
38% is, I'll get to the exact number in a second. But this is basically to avoid a situation like this where for whatever reason you're in a network partition, or you've just got a couple of bad leaders in a row that have tricked you or have propagated this minor fork to you, and you end up locking yourself out, or worst case, you end up rooting 5,
Right.
And once you root 5, there's no going back, right?
Right.
So we have this check that basically as you go, make sure that you're somewhat synchronized with the cluster and people agree with you. So that way you avoid those situations.
Okay. Because you don't want to accidentally just lock yourself out for a very long time.
Right.
Okay.
Yeah. Okay. And then, the 38% number covers the final part of Tower BFT, which is actually what this confirmed means, and the guarantees that we have about confirmed.
Okay.
So we call this optimistically confirmed. I can't spell. And the guarantee that we provide for optimistic confirmation is it will be rooted or finalized unless 5% slashed. So anything that reaches this confirmation level of 66% will eventually be finalized, unless you have specific scenarios where at least 5% of total stake has committed a slashable violation.
Got it. So it's 30. That's why it's 38, because it's 5 plus 30. 5 plus 30.
5 plus the super minority.
Got it.
And so it's not to say that if 5% perform a slashing violation, all optimistically confirmed blocks are going to be rolled back. It's just there is a slim chance that it does get rolled back if at least 5% gets slashed. There needs to be a couple more things that happen, but that's the guarantee that we give.
Got it.
So most apps, RPCs, they use optimistically confirmed because in our history, it's never been rolled back.
Right. And the reason why it's never been, because there's never been social slashing happening.
Right. Or there hasn't been 5%. The more accurate thing is there hasn't been 5% that have committed a slashable violation.
Okay.
And so they all get finalized. The nice part about optimistic confirmation is that it can happen, within one slot, because you just need 66% to
If everybody voted on that same slot,
immediately, then it can get optimistically confirmed. If you're waiting for finalized, you have to wait till it becomes rooted. And for something to get rooted, there needs to be at least 31 votes on top of it,
right,
for it to eventually get pushed off the tower.
Right. So it's a lot longer.
Yeah.
31 times 400 milliseconds, roughly.
Exactly. Yeah. And then the one other thing I should mention is that these tower sync transactions, the ones where you're syncing the vote account tower with your local tower, those are propagated through the TPU like any other transaction. But because they're, so critical to to the blockchain, we also propagate them through gossip.
Okay.
So there is some redundancy there.
Okay.
So this confirmed could also, could be observed through gossip. You don't necessarily need to wait for the block to be built on it. Usually that happens because gossip propagation is slower. But so in theory it could happen, sub-slot.
Got it.
Okay, and then the way that we guarantee this is when you perform a switch. So to take our example from before, you voted on 7 or whatever, something here, and then you're switching on this fork. Switch. So the first thing is lockout, obviously, and that's what we talked about before,
right?
Which is making sure that your tower has expired enough.
Yeah, we're checking all the lockout expirations. If you try to switch beforehand, you're going to run into problems.
Yeah, and then the second thing is this thing called the switching proof. And the idea behind this is greater than 38% is locked out on your last vote. So the idea here is that if there is at least 38% not on your fork, so my last vote was 8, and in this example, there is maybe only 49% here. If there is greater than 38% not on your fork and they're locked out on your slot, so say, 51% of people
Was on that fork.
is on this fork. And since they voted for 9, they are locked out on 8.
Right.
The idea here is that 8 can never be optimistically confirmed.
Because this is a heavier weighted fork choice, and they have 38% locked on last vote. Which one's your last vote again?
So in this example, let's say my last vote is, last vote is 8.
Okay.
And then I guess to illustrate this better, let's just say the slot number on this one was actually 7. Okay.
Okay.
Is that too confusing? Sure.
I'm just trying to think of like the tower, right?
Yeah. So you're replaying, you look at the vote accounts, right?
Right.
And then you see that, 51% of stake has a tower where the top of the tower is 7 with a lockout of 2.
Right. So the lockout expiration is 9.
Lockout expiration is 9. And your last vote is 8.
Okay.
Right. So these guys, all 51% of them are locked out on 8. Right.
So they can't. Right. Okay, so they can never vote for 8.
They can never vote for 8. So there's no chance that 8 will be optimistically confirmed.
Right. They would
At
have
this
to wait
point.
for a later block to be optimistically confirmed.
Exactly.
Like for we would have to wait until 10. I guess.
Yeah. They would have to wait until 10. So since that's true, then it's fine for me to switch off of 8.
Okay.
You could have some weird scenario where, like 8 isn't, you go over here and then maybe come back. But for the time being, 8 has no chance of being optimistically confirmed.
Right. So you have to move on.
So you're allowed to move on.
Okay. Is
that-
this where you can remove 8 from your tower?
The rules for moving on are the same. So like you're voting on 12, or something, you have to wait for 8 to pop off your tower.
Okay.
It's the same as the lockout, where once 8 expires, then you're allowed to vote for something not containing 8.
Got it. Okay. That's an interesting choice. I guess it's just to keep you from like getting locked out forever potentially.
This is actually the protection that allows us to make this clean.
Right.
Because the idea here is that, 5% of stake can be slashed.
Right.
So
So will be finalized eventually is the okay. Got
yeah.
it.
So the idea is that, like 5% is going to do whatever. So 38 minus 5 is 33. If 33% of the stake has voted on 7, that means 8 can never get 66%.
Right. You're just waiting on like the later one so you can potentially switch back and like it would be voted on a later block which could include the fork, but 8 specifically can't be. So you can end up waiting a decent amount of time if it keeps forking.
Yeah. And then the nice part about this also is that once something reaches optimistic confirmation, so this has 67%, you'll never be able to switch off of this because this condition number 2 can never be met.
Yeah, it'll never ever be that. That's
Yeah.
why it's fine. Like as soon as 67%, you're just like, I don't care about it anymore.
Yeah, exactly. You would have to see more than 5% commit a slashing violation, right? Because you need 38%. Right now, in the worst case, you have 67 here and you have, like 33% here, right?
Right.
That's still not enough for you to satisfy the switching proof.
Can't get it.
But if 5%, like say 6% of these guys commit a violation, they violate this, and then they switch their vote to here, now you have 39% here.
Right.
And then the rest of the people could switch.
Right. Okay. So that's just between like confirm and finalize, but because so we're always looking for the slashable events then.
Yeah. So for this scenario to happen, 6% would have to commit a slashable offense to switch their vote from here. And even if that does happen, the rest of them are not going to switch because the weight of this fork is 39. The weight of this fork
you'll
is
run
now
into this kind of-
61. Yeah, you're still going to stay on that. That's why I said that if 5% are slashed, it doesn't necessarily mean it's going to be rolled back. There would have to be other events also, as in like,
Right.
bugs in fork choice or some votes not being observed.
Right. It might be even more than 5%.
Or more than 5%.
Probably have to be a decent amount just to switch as well.
Exactly, yeah.
Do we ever see that? I guess we haven't because nothing that's been optimistically confirmed hasn't been finalized.
Yeah, so far nothing that's OC has not been finalized. But
Okay.
in theory, yeah, if enough of stake performs this slashable offense.
Got it. Do we ever see like this type of thing like often?
Yeah, that happens. Competing forks happen all the time. I mean, on something like testnet, it's like 95% of the time it's just a straight line.
Right.
On mainnet, you get more of these types of situations where leader is slow to broadcast their last block, and then you have a fork, and then when there's like super adversarial network conditions, like when the Hetzner data center went down, all of a sudden like 20% of stake is offline or something like that. Then you have a bunch of skip slots and people building forks off of what they think is the correct heaviest fork,
because they haven't seen everything. They're waiting for things basically.
Exactly. And then the other one is the epoch boundary. So the first block after the epoch boundary always takes a large amount of compute, because apart from the regular transactions that go into the block, it has to do all of the rewards calculations and all of those. And because that takes a long time to compute, you might have this type of scenario where people skip because they haven't received that block yet.
Right, they're waiting for the rewards calculation.
Yes. Or they receive the block, but then they have to run the rewards calculation themselves to verify the block. And then,
before continuing.
Yeah, exactly.
Got it. All right, cool. Is there anything that you think we've missed with Tower BFT?
I think this is pretty much everything. Once something is rooted, then you can remove. We wait until it's super majority rooted, which is like rooted by 66%, and then once that happens, you can clean up all of the bookkeeping, which keeps the validator running.
All right, cool. Yeah, I think we could probably talk about consensus like all day.
Yeah.
We've probably only scraped the surface of it.
Yeah, especially if we get into like duplicate block consensus or, some of them.
Sounds like a future thing that we'll talk about.
Yeah.
All right, cool. Well, thank you for joining me today and teaching me about consensus. Did not know, I think, any of this, so it's great to learn it.
Nice.
And then we'll see you all next week.
Cool. Thank you.